Okay, we've done the first commit. So if I issue some command like get status, I'm expecting my get telling me that nothing to commit because I've taken a snapshot of the folder. Now, before moving more on commit, let's try to understand what's happened if I change the content of one file. As an example, I put a nice comment in the file, I save the file, and if I issue get status, I'm not surprised by the fact that Git tells me that I have one modified file. So Git is telling me, hey, you modified the file src allocate.ts. So this file is changed, respect the latest snapshot file. So I can also issue a get diff, and Git is able to tell me that I've added a part of a comment into a file. And that's the first nice functionality I'm expecting from a virtual file system made for store source files. The ability to understand which file were modified, respect the latest snapshot I've taken, and give me a diff. Now, let's suppose I want to create another snapshot of the folder containing my modification. The first command I need to issue is git add, because even if the file is modified, add does not mean add these files to source control. It means add the files to the next snapshot. So I can always use git add -- all, telling it that I'm going to include in the next snapshot all changed file. When I issue git add -- all, I can do get status, and get status tells me that this file is changes to be committed. So if I get ls files, I can verify that the files are there. If I can use -v -stage, and I have --stage, I have the hash of the allocate file is changed because I've changed the content, and I can issue a get commit -m, and a comment is needed. The comment is needed, my second commit. Okay, sorry. Now I have created my second commit, and that's the ID of the commit. So I can issue a classic get cat file -p and print the raw content of the commit. And I have one nice thing. First of all, I have the classic line with the tree that contains the address of the blob, storing all the content of my directory. And then I have a new line that is not present in the previous commit that point to the parent commit. So that's important. Each commit contains a link to previous commit or multiple commits. We will see in the subsequent video how this is possible. For now, let's see and let's understand that each commit contains the content of the parent commit, unless the only notable exception is the first commit, because being the first commit has no parent. But now, before moving on, I want to show you something that can sometimes surprise the newcomers to Git, especially people that comes from another source control. Let's make another simple example. In the simple example, I modified again the allocate, and I say another comment. So I'm saving the file, I'm issuing get status, and get status tells me that the allocate.ts is modified. Now I'm issue get add -- all, asking it to include all the modification in the next snapshot. I can issue get status, verifying that the file was indeed included in changes to be committed, and then I'm not committing anything, okay? I forget, or I'm not willing to commit anything. So I add another line, okay? Now, with this another line, when I'm issuing get status, what you expect the output to be? You can be surprised by the fact that hello Git file is included both as changes to be committed and changes not staged for commit. This is one of the facts that surprised the newcomers to Git. Because how is it possible for a file to be in two different situations? Well, if you understood how Git works internally, it's simple. I had modified the first time this file, and then I've added to the index. So Git took the content of the file, stored inside internal database, and the file is ready to be committed. Then I change again the files. Now I have a strange situation because the old content, the old modified content was ready to be committed, but I've modified again the file. So the object stored inside the internal Git database, it's not correct. Basically, what Git does, it uses Git ls files. So Git uses the index binary file to understand what's going on. So he found that the hello Git TypeScript has this hash, and then he verified that the hash of the current file is not the same. So the file is changed, but it stores also that this is a new content added by git add. So I'm in this strange situation. Yeah, you can exit from this situation simply issuing git add -- all again. And if you are about to say get status, yeah, you have now a standard situation where the modification are ready to be committed. And if I'm issue git ls file again, the hash of hello Git TypeScript is 28a and is different from the previous hash. So when git add is used, git simply take the new content, the actual content of the file, will create another object and will override the index without any problem. So actually the situation is normal again. To conclude this simple video, I want to show you another interesting thing. So I know that I've modified my hello Git TypeScript adding another comment. Then I've added to the index. Then I've added with git add. Then I modified again and added again. And now if I'm issuing a git ls file -v stage, I verify that this is the actual hash of the hello Git. But if you follow, if you understood how Git works, Git is a big key value database. And when I issued git add -- all, when the file was in the original content with only the another comment line added, it was indeed added inside the Git database. So I can use particular command you're not going to use a lot. And a git file system check lost and found. This is an internal command that Git used to check the internal database and tell me and gives me all the objects that are in lost and found. So object not pointed by anything. And I have one object. And what is inside that object? Okay, git cat file -p. Let's see what's inside that content, that file, that entry in the database. Oh, it is the content of the TypeScript file before I've added the third line. So the idea is every entry in the Git internal database is pointed by some other object, because my latest commit contains a reference to the tree. The tree contains files, whole subdirectory and files. So ending in the end, all the objects that are inside Git database are usually reached by some information, by some other object. But in reality, there are a lot of objects that get lost because they are not pointed by anything. In my situation, when I modified the file, adding the second line and issuing the git add -- all command, I asked Git to prepare those files to be included in the commit. So Git stores the file in internal database and then store the ID of the object inside the index file. But when I added the third line and then issue a git add -- all again, I've overridden that entry into the index because I've stored the new content inside Git database, took the ID of the object and stores inside the index. The previous address with only the second added line was overridden in the index and get not referenced by anything. So I can use git cat file to verify that this object is indeed what I have. So this is not a command, git fshk. It's not a command you are using almost never, but it is useful for me to show you that actually, when you issue a git add, actually you are asking Git to store all file inside this internal key value database and writing the ID in the index. So if you modify again before commit, you are going to somewhat lose that intermediate content. It's not a problem. Git is supposed to have a lot of orphaned blob during the standard working, but nevertheless, this example allows me to make you more familiar on how Git work.